And that orchestrator will basically take your application and manage all the components, whether it's configuration, whether it's scaling, whether it's making sure the application is still running well. And we have an awesome one of these called Azure Kubernetes that runs in our Azure cloud. Now, with .NET Core 3, it's the first version of .NET Core that really enables you to build microservices. So what we've done is we've added a bunch of new features. One is we have something called gRPC. What gRPC is, it's a form of communication that gives you strongly typed contracts between the application. But what makes it unique is it actually works across all developer technologies. We're going to show it in the context of .NET and C# today. But what's cool is you can actually build a microservice using gRPC, and you can call it from Java, you can call it from Node, you can call it from Python. Any of the languages you want will support this. The next thing is worker services. While we built great web frameworks the last couple of years, as you start thinking about microservices, you want these long-running applications that handle responses, requests and responses. And so we now have a first-class template inside of Visual Studio and .NET Core 3 that lets you build these worker services. What's cool about this is you get all the same features. You get the configuration, the dependency injection, all the logging, all those things that .NET Core brings are available there as well. And we're going to show that a little bit later on. And then finally, as you build these APIs, you want to make sure they're super secure. And so what we've done is we've actually worked with one of our partners to make sure that you can actually secure your endpoints using Identity Server. And so with that, what I'm going to do next is we're going to have Glenn Condron come on stage, and we're going to build a .NET Core 3 microservice and host it up in Azure.
Hello.
Hey, Glenn.
Hi, how's it going?
It's going great. Why don't you switch to your machine and let's show us, a microservice.
Yeah, so bit of context for what we're going to do here is I am going to build this weather microservice, this service, and then all of my friends after this, they're all going to come in and they're going to consume this thing from an AKS cluster. So I am going to encapsulate the logic of going and grabbing the weather data. I'm going to cache it locally, make sure I honor expires headers. It's not complicated, but it's not trivial, so we'll make our own service for it instead of having everybody talk to the weather API themselves.
Show us some
so
code.
What I have here is I have just a normal file new gRPC service. I have a console app, and I have a not standard class library we're going to use later, but they're all standard, except that in my weather app, I have already set up some config for the URI, and I've put in some user secrets and stuff so that you all don't try and steal all of my tokens. So first thing we need is a worker. So I am going to add this class. We're going to call it weather worker, right? And this thing's responsibility is going to be to go and grab the weather data and get it in the cache locally, right? And like this. So I have some snippets for pretty much all of my code. And so this inherits from background service, which we had a little while ago. This is how you can add a service that'll run forever. I've got to do some logging, some config. I need config to get my URI, and then in Kubernetes, it actually uses the Kubernetes config provider to grab all of the secrets from Kubernetes secrets, which is kind of cool. I have a hard-coded location ID because you don't need any other weather than what's in Redmond. And then the meat of this is this execute async method. And all it's going to do is loop for as long as the app is going, make a HTTP client, going to go and call the weather API, get some JSON response, use the new system text JSON that we added to deserialize that to a type, and then cache it, and then it's going to do that every 10 minutes forever for as long as the app's running. And so I'm missing this forecast data. This is how does the weather endpoint I'm hitting represent the weather? And so I'm going to add another class to represent that. Call it weather model.cs. If I can not put some extra caps in. So what I did to generate this, I have a snippet here for this now. What I did to generate this and what you can do is I just grabbed an example JSON payload from the API and I just copied and pasted as C# into Visual Studio and just made this whole thing for me. And I'm just going to ignore it.
That's a cool feature. Visual Studio can basically take your JSON and convert it to C# types.
Yeah, absolutely. It's a super cool feature. Okay, so now I have a worker. This is done. I'm good now. But except I need to tell the app that it's got to go run that worker service. So now over here, I'm going to start doing some code. I'm going to add hosted service, which is the name of this feature. Add weather worker, right? And then this needed a few things. It needed like HTTP and like caching, right? So services.add HTTP client, so I can inject the HTTP client, and then I'm going to add the memory cache so that it has a memory cache, right? This now, when I boot this app, it's going to go and every 10 minutes go and get some more weather data. Pretty simple, pretty cool. Now I need an endpoint. So Scott talked earlier about gRPC and some strongly typeness. So this gRPC is a very contract-driven approach to RPC. So I have a snippet here which gives me this proto file, which is the contracts for a gRPC service. And so I have this proto file that says I'm going to make a weather service. It's going to have a get weather streaming endpoint, which it should stream weather constantly. And it has a get weather that just returns you a single whatever the current weather is. And it also defines what the actual response type is. Nice thing about making our own proxy for this weather data is we get to choose the actual surface for our clients and make it relevant and not have too much extraneous data, right? So if we just call this weather.proto, and then in here, the way this actually works is in my CS proj, I have this protobuf element, which references that weather proto. You see the rename worked. Good job, team. And it says it's going to generate server, because the way that gRPC works is you create a contract and then you generate a lot of code. And you just implement the bits that matter, and you leave all the rest to be generated.
Right. I write that contract, and I generate either a client or a server using the tools.
Yeah, exactly. And so then we're going to go create a weather service now from my snippet. And so what we have here is a service that implements this weather base, and that's that generated code that we just talked about. So we just control.myWayToGlory glory here. I have the base class. I have a memory cache because I need to get the data out of the memory cache. And then gRPC doesn't want you to have empty method calls, but because I'm hard coding the weather for Redmond in this case, I've just got this empty type to fill in for the request type. You would probably in most cases have an actual type here that has your data, right?
Yeah, past your location or something.
Yeah, something, yeah. And then I just have this get current weather response. All it does is left-hand, right-hand code to say, take that pasted code, the pasted model earlier, convert it to the one that we want to actually give to all of our friends later. And then get weather returns 1, and then for get weather stream, it just loops for as long as the person is connected. It just grabs the data out of whatever's in the cache currently and then loops, right? And then this is every 10 seconds just so that it's easy so you can see something. For the sake of the demo, we might actually even make this 2 seconds just so you can see some data constantly changing. We know the data will only actually change every 10 minutes or so, but you want to kind of keep a constant stream happening, right? And then that's it, that's greeter service. So if we'll rename this to weather service so that, you know, just because we can't have a class with a different file name, that'd be terrible. And then in our startup CS, the way you register these services is we have a map gRPC service endpoint, right? So now I can change this to weather service. And that's it. At this point, my app can run and it'll go do its job. And so now you want a client to go grab some of this weather data to test it out. So I added this console app earlier, conveniently, but I also added this weather client lib. So I could go over here to my client console and then add a ref to the proto file and have it generate the client code straight into my console app or any of the .NET stuff that we're going to show today. But what I can also do is I can come over here. I have a completely empty net standard class library except for the default class, which I'm going to delete. All right? And then I can right click on this and say add service reference. And then click add new gRPC service reference, browse to the proto file that I had earlier, that are the same proto file that my weather app is using to generate the server code. And then I can say generate client though here in this drop down, right? Instead of, there's some other options for what you can generate. I'm generating a client in this case. And then just going okay. And this is going to go install all the NuGetty goodness that you need to make gRPC generate code and generate all the types that you need.
So this is pretty cool. So you built a service. So we built our first microservice. We installed gRPC into that, and now you want to write a client, so all you had to do is basically reference that same proto file from your service in your client, and we'll generate all the code for you.
Absolutely, yeah, and then it generates you kind of the base, yeah, it generates you all of the codes for the client's class, yeah, absolutely.
Then all I can do is new it up and start making calls.
Yeah, and so let's look at what that looks like. So I'm just going to add a normal project reference now to my client class library because everybody can now share this net standard class library that has the client code generated in it. Or they can choose to reference it directly. And then in my program CS, I have another snippet here where the client, right? And whoop, I think it's actually the whole class I did this time. And then so yeah, you can see here, like as you just said, this weather client was all generated for me. I just knew it up. I used this channel type to give it the address, and then I have a strongly typed method for get weather async, which was in my contract file.
You just start calling the methods and getting the results back and write them out to the console.
Absolutely. So now I can like control F5 this weather service. It'll spin up on my local machine. We'll see the console output in a sec. It's going to see the output, go fetch the data, and then sit there and be a gRPC endpoint. And then, so here you can see it going and getting the data and then being ready. And then over here, I can then like go debug, start new instance of my client console, and my client console will ping up. It's going to grab a single weather and then just say done in this case, because I'm just calling a single weather endpoint asynchronously. I'm using async like console app that we added a little while ago, and that's like apparently 53 seems reasonable.
So that's pretty awesome. So in just a few minutes, we built a brand new project using the worker service, long running process like you would build a microservice. That goes out and fetches weather from an endpoint somewhere, and then we actually added gRPC to that service, so a client can call into that and get that weather data back.
Yep, absolutely.
Well, let's switch back to the slides for a second, and we'll talk about C#. So, along with .NET Core 3, we're also shipping the next version of C#. Along with .NET Core 3, 8. It has a bunch of new stuff, and we kind of broke it down into buckets. One of the things we think about is we always want to make your code safer to write. We want to make it easier for you to catch the errors early or prevent the errors from ever occurring. And so there's some new features called nullable in C# 8 that try to address some of that stuff. Modern as well. As we look at language, we always are looking at other languages, and we're looking at the patterns that developers are using today. And so one of the cool features we have in C# 8 is async streams, and we're going to show those in a little bit. And then productive. We always want to make you more productive. So the goal of C# is to add the right features and stuff to make it easier for you to write code and write code faster with less text in the screen. At the same time, also tooling all that with Visual Studio Family so you can actually be more productive. So what I'm going to do next, I'm going to bring Mads on, and we're going to take the demo that Glenn had, and Glenn didn't really write it the best way you could. We're going to make it use async streams.
Well, I think Glenn did a fantastic job. It's just that when he...
switch back to the laptop.
Let's switch back to the laptop and look at the proto file that Glenn put up there. There were actually two endpoints here. There was the get weather that he used, that he called just before from the client, and there's a get weather stream, which continues to stream weather down. So that's the one we're going to investigate now. If I can find my way back to the program here. So there's, if you look at the client here, it also has a get weather stream method. So that's probably the one we're going for. And that can't be awaited. Instead, we get something that we're going to explore a little bit. So let's just call it response for now. And let's start drilling into it. So if we say response dot, we see that it has a response stream. That sounds streamy. Let's do that. And that one has a read all async. That sounds streamy and async.
That sounds promising.
That's pretty good, right? Let's do that one. So if I call that, then what do I get back? We can actually drill into that as well. Let's try to just F12 our way through. There's read all async. It returns something called iasync enumerable of t. And iasync enumerable, if people remember, IEnumerable is a core type, and IEnumerable of t is a core type in .NET that you can for each and produce new ones out from the language as well with yield return, with iterators. And so iasync enumerable is just it's just an async version of that. And we can actually, if we take a very quick look down the rabbit hole here, iasync enumerable, just like enumerable has a get enumerator, this has a get async enumerator, and if we drill into that, you can see that it has a current property for the value that we're currently looking at, and it has a move next method, but this one is async, right? So if you think about it, this is a stream where you can pull elements, but every time you pull a new one, you do it asynchronously, so it might take time, and you have to wait it. Okay, so that's how that works under the hood. Now, at the language level, we would like to support for eaching over these. So let's try to for each over the thing that we got back from our drilling here. So let's call that forecasts with an S, because we hope there are multiple. And then we can, let's try to for each over it. For each var forecast in forecasts. And now what we get is, oh, this thing can't actually be for each. And that's because in C# we decided you shouldn't just be able to for each over async things, because then you can't look at your code and see
And know they're async.
and know that you're doing something async, right? We want every await to be visible in the source code, so you can know that you're sort of getting off the thread, you're doing an async thing, it's a point where context might switch and so on. So what we have instead is an await for each syntax that then you use when you have an I async enumerable. And let's just put the right curlies in there for the beauty contest, and we're good.
So now we've actually called a streaming endpoint, and now we sat and did an async loop around that endpoint.
Yes.
The code, honestly, to me, Mads, you just took a for each and just added a wait in front of it, and it just works.
I tried to make a big deal of it, but it's actually pretty simple.
Pretty amazing. I mean,
Yeah.
it's a complicated feature, but it looks so simple when you actually use it. So.
Right, and there's more to it. You can actually yield return in an async method as well now, returning async enumerable. So we have async yield return. That's pretty useful, right?
Amazing.
And also, there's cancellation built in that I kind of skipped over here, but so there's a little more to it.
Well,
the idea is it should be simple.
Later today, you're going to have more talks on C#8 where you're going to drill into more and more features than just the async stream that we showed.
That's exactly right. Yeah.
So
just after little after the keynote, there'll be 2 talks on
perfect.
C#8.
Thank you. Let's go back to the slides, and we're going to talk about desktop. So today we have still millions of developers building desktop applications. You might ask why? Well, because desktop applications are simple to write. Web applications are hard. They require knowing HTML, CSS, JavaScript, and a bunch of stuff. Desktop applications in .NET, you can just drag some controls to a form, write some code. They're very quick and simple. We've made them much, much better in .NET Core 3. So in .NET Core 3, we've brought WinForms and WPF to .NET Core. But you get all the benefits of .NET Core. So one of those benefits is side-by-side deployments. You no longer have to worry about an update of the framework breaking your application. You can even take the app or the framework and compile it directly into a single exe for your application. So you just hand that application to any machine. It doesn't even have to have .NET Core on it. That's a cool feature in .NET Core 3. We've made all of the Windows 10 APIs available to these applications as well, so you can call all the things. If you want to get Bluetooth or something like that, you can do that from a WinForm or WPF application. And then finally, because it's .NET Core, we do all of it open source, and so we've open sourced WinForms and WPF. Now, what I'm going to do next is talk about App Center. This is a new announcement today. I started off as a web developer, and App Center for desktop applications really excites me, because for the first time ever, if you're a web developer, you can just add some kind of analytics to your website, and you're going to know how many people called it, where they're from, how long they were on the site. Wouldn't you want that same information for your desktop applications? If you're building a desktop application, you likely want to know how many times it's been used. Are all the features being used? And so by adding App Center to your application, you get all those benefits. App Center can also be used to deploy the application, including beta versions of the applications, to a smaller set of people. So super excited to announce that.